Hi, and welcome to my screencast Oracle Transparent Data Encryption in Action. In this screencast, I will show you how to apply full tablespace encryption, and then I will also show you what it means to have your data encrypted and, more importantly, not encrypted on the storage layer. But before we start, let me introduce myself. My name is Gerald Fensel. I work in Oracle UK as a principal sales consultant. There's a couple of different ways how you can get in contact with me. I do have a blog on blogs.oracle.com, and you can also follow me on Twitter for general updates. You can also ask me questions on Stack Overflow or have a look at some of my coding examples on GitHub. And last but not least, you can of course also look at my YouTube channel where you will find this video later on. Now before we start, let me introduce Transparent Data Encryption. So what is Transparent Data Encryption, or short TDE? Well, it's part of the Oracle Database Advanced Security option. It's not the only, but one of many features of the Advanced Security option. There's many other ways to address security. It's all part of that option. Check it out later on. Why encrypting data? Well, the answer to that is actually quite simple. Because you want to protect your data for leakage or for malicious users, so that they cannot leave your company with confidential data. But why encrypting data within the Oracle database and not on the storage layer or on the application layer or somewhere else? Well, there's many aspects of security, and again, the advanced security options addresses them all, but transparent data encryption addresses the need of writing data encrypted to the file system level. If you encrypt on a file system level, let's say the SAN, or on Linux, anybody who has the permissions to log on physically to that machine sees already unencrypted data, because the encryption happens before the user gets access to the actual data file. So just a normal Unix user can just quite happily see your data. If you do it on the application layer, that's definitely an option too. However, if multiple applications look at the same data, then multiple applications have to know how to encrypt and decrypt that data, which can be a bit of a nightmare depending how many applications you try to point to the same data source. Now, if you encrypt it in the Oracle database, as the name suggests, transparent data encryption is fully transparent to the application and the storage layer. The database does the de and encryption for you. What that means is, as you write data, the database will make sure that the data will be written to file system layer encrypted. But also if an application reads data, the database will decrypt that data once it reads it from the file system layer and passes it back to the application. Therefore, the application has actually no clue that the underlying encryption, that the underlying data is encrypted. Now, let's have a look at what I'm talking about here. I do have a single instance of a 12.102 Oracle database. To this point, Oracle 12.102 is the latest release of the Oracle database. Now, before we start, let's create just a normal non-encrypted tablespace. That is, with the create tablespace command, just of a size of 10 megabytes. Let's execute this one. Great, my tablespace got created. Now let's switch over to my test user of my database and create the table and fill it with some data. Now I do have a simple table for credit cards, which has a name for the credit card owner and the credit card number. Let's create it and put it in our NoNTS tablespace that we have just created. Great, our table is created. Now let's just fill it with 3 dummy records with some credit card numbers and commit it to the database. Alright, data is in. Now, the Oracle database doesn't necessarily write data right away to the data files, but writes it into a memory area called buffer cache, and only the redo goes onto the redo logs when you issue a commit. So we have to make sure that our data actually goes into the data files. Let's issue a checkpoint. There we go. Our data should now be all in the data file, or the tablespace and data file. Let's have a look. So I'm a Unix user now. I'm here on a shell and logged on physically on the machine, and I do have access to the data file because, well, I got the Oracle username and password from some person who gave it to me. So let's have a look. So those are all my data files, and as you can see, here is my data file of my non-encrypted tablespace. Now let's just apply a simple Unix strings commands and print out every printable character of that tablespace. As you can see, this is all I have in my tablespace. Well, I just inserted 3 records, fair enough, so the tablespace is rather small and my data file is rather small. But as you can see, you can quite happily identify those credit card numbers and the names to it. Everything is just plain text. Now, if I would be a malicious user on the Unix machine directly, I cannot take this information away with you even not realizing that there was just a data breach. Now let's see what happens if I put this data, move it over into an encrypted tablespace. So therefore I have to first create an encrypted tablespace, and I do this with this command. The difference to the other one is that I actually specify here to use encryption with the algorithm AES 256 bits, and the default storage is to encrypt the data. So let's create this tablespace. Great, tablespace is created. Just a quick check. We will see, oops, sorry. We will see here is the data file of my encrypted tablespace, and it's completely empty right now. So now let's move our data from before over. All I have to do is just to issue alter table move tablespace, and my table will be moved into the encrypted tablespace, and the database will take care of encrypting the data for me. So let's just issue this command. And my table was moved. Let's have a look whether I can see the same data now in my encrypted tablespace. Oh, there we go. As you can see, my data is now fully encrypted and completely useless to any Unix user who got access to the database or data files. I can also take this now, any backup that it goes or anywhere I copy this, the data will be encrypted. And if I don't have the right key on the other side of the database, I won't be able to open it. So with this, you can make sure that data remains secure on your file system storage layer. Now, this was my short little demo of how to apply full tablespace encryption on the Oracle database. How can you find more if you're more interested? Well, you can definitely go onto oracle.com, Tech Network, Database Options, Advanced Security, where you get actually the full feature list of the advanced security option and not only transparent data encryption. You can also go on youtube.com, search for Oracle Learning Library, and in there search for TDE or just search for Oracle TDE, and you will find a couple of other screencasts that show you how to apply or set up transparent data encryption. With that, thank you very much for your attention.